Problems on bearings. We're going to make use of the application of sine and cosine rules on solving bearing problems. So before we apply bearing problems, we're going to find out that we would have to make use of the principles of the angles formed when a transversal or transversals cut parallel lines. I enumerated on those principles in one of the videos in this series on bearing. So to get the understanding of those principles, you may have to pause this video to refresh your mind on those principles, because whatever I'm going to do here and in the subsequent videos will be drawing on those principles because it will be necessary. So let's proceed. So a village Y is 15 kilometers from a point X. So in our last video, I always said that when it comes to problems on bearings, no matter how the question is given, always start by taking note of this word from, which means that's where the reference from is the reference, the points. So it goes with from which points, from point X. So that's where the bearing is plotted. So from a point X on a bearing of 0 to 5. So Y is, the direction of Y is measured from the point X, and the X is bearing of 0 to 5 degrees. So if 0 to 5 degrees, it means it's going to go up this way. So I'm going to put my X here, and so let's see. Okay, X, point X, okay, to this line compass. So 0 to 25 degrees will be something like this. So from the north, 0 to 25 degrees, and so this is point X, and wherever it meets, you draw your cardinal point or your compass there also, and make sure that this line falls naturally into the one of the points of the cardinal, one of the planes of the cardinal of the compass, and in this case it will fall into the third quadrant naturally. So this is point X in the case here. So this is point Y, sorry, this is point Y. Then okay, we're giving a distance 15 kilometers, and then it says that another village Z is 20 kilometers from X. Take note of the word from again. So it is still on from X. From X again, on a bearing of 115 degrees plus 115 degrees. So 115 degrees would be on, and remember this 3-digit bearing. So from the north, 115 degrees would be on the fourth quadrant, which is no, would be on the second quadrant, because for in the other video I explained how quadrant works on bearing. So this is a first, is a second, this is a third, and this is a fourth. So 115 is here, okay, and the distance is 20 kilometers. So this should be a bit far from this, because if you are to use drawing to use technical drawing, or if you have to use construction to get these angles. So if you are, this line will be longer than this one, say 20 kilometers to 20 kilometers. Okay, so Z naturally this R is going to be to fall on the fourth quadrant on your compass. So this is point C. Let me put it here, point C. So you're going to link these two places together. So this will be, so okay, that's perfect. So these are shape. Okay, so now let's begin. Don't forget this from the north to this line, which indicates the bearing of Z from X is 115 degrees. So I'm going to write it here. 115 degrees, and here. So when the bearing of y from x is 25 degrees, so there will be an angle here left. So I'm going to call here E. And then for this particular case, bearing of c from x, there will be an angle here. So let's I'm going to call here B. Alright, so 20 kilometers. So the question says calculate the distance YZ. So we need to find this distance. So now let's analyze the diagram. We must analyze the diagram and ensure that we fully resolve the triangle. We fully resolve the triangle. How do we resolve the triangle? We do this by ensuring that we get all the angles that are necessary for us to be able to calculate the distance that is required to be calculated. So from here, we're going to say A is equal to 25. O is equal to 90 degrees minus 25 degrees, and that will give us 65 degrees. Why is it so? When it's a complementary angles. So in that video, I didn't mention complementary angles. Complementary angles are two angles that, when added together, will give you 90 degrees. So you already know that this is what we have here. This is a north, and we have a line, and this is 25 degrees. And I told you that in the quadrants, from the north to the east is 90, east to the south is 90, south to the west is 90. So this is 90, this is 90, this is 90, this is 90. So the two angles, this line is between this from the north and east. So if north to this line is 25 degrees, what will be this remaining angle? That's where, so theta. So theta plus 25 degrees equal to 90 degrees. So this is an example of complementary angles. If two angles add up to give you 180 degrees, then we say the angles are supplementary. In this case, we are making use of complementary angles. Okay. So the reason is that 90 degrees minus 25 degrees, because the reason is complementary angles. So we also need to know this angle, because both A and B will not form this side of angle X in this triangle. So make up angle X on this triangle, or Y angle XC on this triangle. So we need to know A, we need to know B. So B, how can we analyze B? So B will give us, remember that this line, so here is give us B would be okay, let's call it here. We need to know here also. So this will give us C. This is C. Alright, so there's a reason why. Okay, let me go on with an analysis. So if we have for this part 115 degrees, this bearing forms a line like this. So if you look at it clearly, this is 115 degrees, and then this is this angle C. Okay, so that's why on the other video I told you about transversal and parallel lines, and I told you about those properties, because I emphasize that why we went on, or why we're going to go on this taking this bearing series. We're going to make use of those rules or those angle properties. So this is the application. This is how we make use of them. Now if you look at this line here, what do you see? This angle on the straight line 115 degrees and C. So to get C, this remaining angle on this straight line, because we need to get B here. So to get C, first of all, we're going to say C plus 115 degrees is equal to 180 degrees. So C is equal to 180 degrees minus 115 degrees. So C will be what? C is equal to 180 minus 115. That's 65 degrees. 65 degrees. Alright, so that indicates that C is what? C is 65 degrees. C is also 65 degrees. Now C and B, they are in this quadrant, and the second quadrant. C and B, they are also angles, two angles that make up 90 degrees in this quadrant. Like this, you find them in this quadrant. This is 90 degrees, and then you have this is C. I want to know B because these two make up this part of this angle, and we need B, which is part of this triangle, for us to be able to get the whole of this angle here. So C and B, so we see C plus B is equal to 90 degrees. So C, which is equal to C plus B is equal to 90 degrees, and C is so what do we say? This is equal to what? Also complementary angles again. So C is 65 degrees. 65 degrees plus B is equal to 90 degrees, and B is equal to 90 degrees minus 65 degrees. So B is equal to what? 90 minus 65 equal to 25 degrees. 25 degrees. So that's the value of B. Now we need to get, because from our analysis of this information given to us, we got a triangle, and for us to be able to calculate YZ, we are going to use or make use of either the sine rule or the cosine rule, whichever one fulfills okay, whatever the information here, if it fulfills any of the condition of either the sine rule or the cosine rule here, that's the rule we are going to use. So for us to be able to know whether we're going to use the sine or the cosine, we must be able to analyze the triangle that we got from this information and make sure that all the angles are correctly calculated or gotten. So B is equal to 25 degrees. Now we need to know A and A plus B, which make up from this line to this line. Okay, and from here, the angle between this XY and XZ is as a result of A and B. So A plus B will give us A plus B is equal to 20. A is 65 degrees. 65 degrees plus 25 degrees, so that equals 90 degrees. So this will give us angle. This is 90 degrees. Okay. Now, if that is so, our resultant angle would now look like this. So this is 90 degrees. You may not need to draw the diagram again, but it's because I'm calculating and I need to show you that this is what it will result to. So this is point X. Here we have the 90 degrees, and then we can call this Y, and then Z. So into X, Z is 20 kilometers, XZ is 20 kilometers, and XY is 15 kilometers. 15 kilometers, and we are to calculate the distance between Y and C. So now, since we have a right angle triangle, we're going to use Pythagoras theorem. Since the question says we should find the distance between the distance YZ, so using Pythagoras theorem, y line YZ squared is equal to 15 squared plus so what line YX squared plus line XZ squared. So line YZ squared, which is this distance, is equal to 15 squared plus 20 squared. 15 squared is 225 plus 20 squared is equal to 400, and altogether we have 625. So line YZ is equal to the square root of 625, and this will give us square root of 625, 25. So therefore line YZ is equal to 25 kilometers. 25 kilometers. So that's the answer. A boat sails 24 kilometers from a port X. From what point? A port X. On a bearing of 065 degrees. So from X, 065 degrees. So let's make a sketch. 0, this is X, and this is your compass. 065 degrees. 065 degrees. So a boat sails 24 kilometers from a port X on a bearing 065 degrees, and thereafter, after 10 kilometers on the bearing of 155 degrees. So, and thereafter, so when it goes to this point, it Let's bring it down. When you go to this point, we're not giving the description of this point, so let me use any later. So let's say x, y, let me use y here. So from point x, so it says, and thereafter, after 10 kilometers foot, let's say 24 kilometers here, the distance here, 24 kilometers, and thereafter from y, 110, 150, 55 degrees. So 105 degrees is from 2 digit there from the north, so the line here will give us 155 degrees on 10 kilometers. So that's where it's going to be. So the question says, find 155 degrees. What is the bearing of, what's the distance of the boat from X? So from here down to this point, so call here Z. So it's from here, remember from Z, bearing of Z from Y is 115, 155 rather, 155 degrees. Right. So let's call here E. So if you are going with this line, remember that if you need to know this line, since you already know this angle here given to you, and you need to know here, you're going to, whatever you put here, let's say yes, A plus this angle will give you 90 degrees, because if you're 65 degrees, this when the angle would be 90 degrees minus 65 degrees, which is 25 degrees. But now for this part here, okay, since we need to know this angle will help us in our calculation analyze here. So let's call it A. We can know this angle, and here let's call this AB. So let's come here. Okay, here's 10 kilometers. All right. So angle A is equal to 65 degrees. Why? It's the alternate angles, because A is alternate to 65 degrees here. So what about B? B is gotten from angles on the straight line. Right? B is equal to 180 degrees minus 155 degrees. Why? Angles on a line. Okay, so B is equal to 180 minus 155. That's 25 degrees. Okay, so A plus B will give us so X angle W we see in triangle X W Z. So this will give us X angle W Z is equal to, and sum of angles here, this whole place will give us, so that we get the total angle of this the total angle here on triangle XWZ will give us 65 degrees for A plus 25 degrees for B, which is equal to 90 degrees. So we end up having a right angle triangle again. So the distance between X and Z will give us using Pythagoras theorem, because it is now a right angle triangle. Using Pythagoras theorem is equal to, so xz squared is equal to xz squared is equal to 24 kilometers squared plus 10 squared, 24 squared 576 plus 10 squared is 100, and that's equal to 676. So line xz is equal to square root of 676. This will give us the value 24 676 76 kilometers as the distance between X and Z. So you might be wondering, so why can't we use the cosine rule, since the condition fulfilled here is the cosine rule 10, 24. The two sides that are given is the two sides are given are between an included angle. Since it's a triangle XYZ, I would say that cosine rule and the sine rule finds application on bearing. So finds application in bearing. But why are you not using the sine or cosine rule? Or sorry, the cosine rule particularly in this case? Okay, if we use it, we can use the cosine rule. If we do, we still get back to Pythagoras theorem. Got it? So using the cosine rule. Using the cosine rule, since it's 90 degrees, we still get back to Pythagoras theorem. So you say xz squared, which is the side opposite the given angle and the graded angle. So we say xz squared is equal to 24 squared plus 10 squared minus 2 times 24 times 10 times cos 90 degrees. Now, cos 90 degrees. Remember that this part is multiplication. So if you calculate this part, 2 times 24 times 10 times cos 90 degrees, that's 90 degrees. You're going to have 0. So this part will be 0. So this will give us 24 squared plus 10 squared minus 0. So if it's minus 0, by the time you add these two parts, this will give us 676. 676 minus 0, and 0 is nothing. So you come back to Pythagoras theorem, which is exactly 24 squared plus 10 squared. And what do you have here? 24 squared plus 10 squared. So whenever you get 90 degrees as one of the angles of a triangle from analysis of the information given to you on bearing, you just move down to using Pythagoras theorem. There's no point going using the cosine rule. But if you decide to use the cosine rule, you still get back to Pythagoras theorem and your answer will still be the same. A ship sails 5 kilometers due west. So if questions like this, you don't see from. So what do? Just go with the way the question is put. A ship sails 5 kilometers due west. So 5 kilometers due west would be, so let's see, we have so due west will be is our compass or our cardinal. So we have due west, this is the western direction, so it's going to come this way, give us due west, and that will give us 5 kilometers distance. Okay. And then 7 kilometers due south. So from this point, travel 7 kilometers due south. So if you put your cardinal point here, south would be like this. So now that is it. Okay, so okay, now due south, find correct to the nearest degree is bearing from the original position. So you join this point to this point, I will give you the bearing. So if you indicate here as a cardinal, it will look like this. So let's call this point, the original point, as E, and then this point B, and then the final point as C. Okay, so this is 7 kilometers. 7 kilometers. So we want to know the distance between C and E. Oh no, the bearing. Find correct to the nearest degree is bearing from the original position. So the bearing of the ship that started from E, and goes to C at final destination. First of all, from E to the west, and then which is point B, and then from B to C. To get the bearing of the ship from its original position means this line is connecting the ship from its original position to the final position. So you're going to take your angular measurement from here to meet this line. So whatever this gives us is the bearing of C from E. However, for us to be able to do that, we need to get this angle known. So let's call this angle, let's call this E. Already we know that from this north to the south here is 180 degrees. So you don't need to worry about that. So for us to get this known, we can actually get to know alternate angles, which is theta. So this will alternate to this side, and for us to do that, we need to know this angle too. So let's call this theta. Okay, so now let's go on with our calculation. So what do we have here? This is 90 degrees. So for us to know, for us to get this angle, we need to use okay, let's use, first of all, let's get this distance, which is AC, line AC. Is it relevant? Yes, it is for our calculation of this angle, because for us to use, in this case, we have two angles given, so we can get to yeah, we can, for us to, okay, we can use cosine rule, and the only reason why we're going to use cosine rule was because we wanted to know AC, but if we use cosine rule, it will get back to Pythagoras theorem, which means we get to know here. So for us to use sine rule, we need the ratio of the known angle, which is 90 degrees to the side, but we don't know the side. This is why we need to know this side using cosine rule or Pythagoras theorem. So we're going to say using Pythagoras theorem, in Pythagoras theorem, we can get to know here. So that when we are using sine rule, we can have the ratio of this angle and this side. Then this angle that we're going to look for this side. So that way we can use the sine rule appropriately. Using Pythagoras theorem, we can say that AC squared, line AC squared is equal to 5 squared plus 7 squared, which gives us 25 plus 49. 25 plus 49, 74. So line AC is the square root of 74. So line AC is equal to square root of 74, 8.60 kilometers. So that's the square root of, so the distance between the distance of the ship from its original point, between its original point and its final point or final destination. So why was this necessary? Because we need to get this angle, and for us to get this angle, now we have 90 degrees and this angle. So that's two angles given on two sides. So for us to be able to use the sine rule, we must have a side given, and that side must be opposite one of the known angles, so that we can compare it against the ratio of another angle to its side, which either is that angle that we're comparing to is not given, or the angle is given but the side is not known. But in this case, the side is known but the angle is not given. So I'm going to say using sine rule, so sine 90 degrees over this side, which we use Pythagoras theorem to get 8.60 is equal to, this is the angle we are going to calculate, sine theta over the side, which is 5. So sine theta is equal to 5 sine 90 degrees over 8.60. So sine theta is equal to 5 sine 90 divided by 8.6, 0.58, 0.5814, 0.5814, and theta is equal to arc sine 0.5814. So theta is equal to 0.5814, 35.55, 35.55, and so 35.55 degrees. So, but that's not the final answer. Now, the reason why we got theta was because we wanted to know the value of A, because theta is alternate to A. So we say A is equal to theta, that's equal to 35.5 degrees. That's 5.55 degrees. What's the reason? Alternate angles. And that will help us in our computing the bearing of C from A. So we say the bearing of C, from A is 180 degrees plus A, and that is equal to 180 degrees plus, what's A? 35.55 degrees. So that's equal to 180 plus 35.55, that's 215.55 degrees. But the question says that we should correct our answer. Our answer should be correct to the nearest degree. So this will give us the nearest degree, approximately 216 degrees to the nearest degree. That's your answer. y is 60 kilometers away from x on a bearing of 135 degrees. So also 135 degrees from our coordinate point will be like this, and then on the end z is 8 kilometers away from x on a bearing of 225 degrees. So this is x. So from point x again, 225 would be like this one. So our diagram will look like, so x is going to be somewhere here. So this is x, and then this is our compass. So y from x is bearing 135 degrees. 135 degrees. And what's the distance? 60 kilometers. 60 kilometers. So this is y. And then from x again, z is 225 degrees. And what's the distance? And the bearing? 80 kilometers. 80 kilometers. So 80 kilometers is slightly longer than 60 kilometers. So it's going to be longer also. Alright, so this will give us so let's get up. Since let's take from our angles given to us on x, 135 degrees. So from the north to the line here, that's 135 degrees. So we need to know this angle, call it A. And then from here, from the north pole to this line is 225 degrees. 225 degrees. So now what will be from here to the south to this angle, we call it B. Altogether, what will be this place? That's A plus B. So we need to find here. So let's call A plus B theta. So let's join this together. This will move naturally to this line. So let's call here point Z. Okay. So now that we've gotten this, now let's analyze. So we say A is equal to 180. Now this is from what the angle that A will be gotten from here to this line. So this is the left angle A to complete from north to south. So that will give us 180 degrees minus 135. 180 degrees minus 135 degrees. And that will give us either angles on a straight line, we say supplementary angles. So we say angles on a line. That's the reason. 180 degrees minus 135. 45 degrees. This equals 45 degrees. So for B is equal to 225 degrees minus 180. 225 degrees minus 180 degrees equals to, so you know that from the north pole to this line is 205 degrees. So which means if we were to get B, we would do simple. What we do simply is that 225 degrees minus 180 to give us B, and that was because whenever B was added to 180 degrees to get to 25 degrees. So 225 degrees minus 180, 225 minus 180 will give us 45 degrees. So A plus B is equal to 45 degrees plus 45 degrees, and that's equal to 90 degrees. So A is 90 degrees. Now to get the question says we should get first of all distance with Z from Y. So using Pythagoras theorem, line Z y squared or yz squared is equal to 80 squared plus 60 squared. So 80 squared (6,400) plus 60 squared 3,600. Altogether 10,000. So line zy for the square root of 10,000. And what is that going to give us? Square root of 10,000, 100 kilometers. So line zy is 100 kilometers. So we'll say therefore the distance of for the distance of z from y is 100 kilometers. So this is A. And B says bearing of z from y. So we're going to get calculate bearing of z from y. Sorry, bearing of z from y. So it's going to be from here to this line. So for us to be able to get the bearing of z from y, we need to know this angle. Now we can't get this angle from here because we don't know this part here, or this line, this angle here, and that's because we don't know this angle here and we don't know this angle here. So even if we get the value of this angle, we cannot subtract from here because we still have this line in the first quadrant. So what do? We get to know here, we can know this angle. Let's call this this sign. Let's put this sign here, or let me use beta instead. So let's angle beta, and then from here, if you know A is 45 degrees, so A will alternate. So let's call this D. So BAD. So let's call here D. So altogether, these are the angles at a point. Angles at a point. Okay, so let's put here. So the distance. Therefore, we're going to say the bearing of z, from y. The bearing of z from y is 360 degrees minus beta plus d. So what we're going to do is to get the value of beta and get the value of d. So we know that okay, so let's get the value of beta for using sine rule. Sine beta over, what's the side facing beta? 80 equals to sine 90 degrees. We're using this side against this side because we know this side. We know this angle and we know this side. We know this side but we don't know this angle. So we're going to use a known angle and known side against a known side and unknown angle. Sine 90 degrees over 100. So sine beta is equal to 80 sine 90 degrees over 100. So sine beta is equal to 80 sine 90 degrees divided by 100, 0.8. So beta is equal to arc sine 0.8. Beta is equal to 0.8. That's 53.13 degrees. Okay, so if beta is 3.13 degrees, what is d? But d is also equal to 45 degrees. Why? Alternate angles. Okay, let me put it this way. D is equal to A, and A, that's equal to 45 degrees. What is the reason? Alternate angles. So the bearing of z from y is equal to 360 degrees. Now look at carefully this angle at the point from this point to this, and then you have an angle, and then you have this. So that's angle at the point, 60 degrees minus beta, and beta is 53.13 degrees plus d is 45 degrees. Plus 45 degrees. What's the reason? Angles at a point. Angles at a point, and that will give me 260 degrees minus 53.13 plus 45, 98.13 degrees. So 360 degrees minus 98, 360 minus 98, 261, 161.87 degrees. What's the instruction? Bearing a z from y. So if you approximate to the nearest degree, we can say approximately 262 degrees to the nearest degree. So therefore, the bearing of z, from y is 262 degrees. A hunter walks 250 meters on a bearing 042 degrees. So let's just take a glimpse of what it will look like. 042 degrees. So let's say 042 degrees will be like there. Okay, and then calculate correctly the nearest kilometer, the vertical height mode. Okay, so at this point, so let's say this is the starting point x and s, y. Right. So from here, the x point moved this way, and then you have this. So this is y, and then the distance is what? And hunter moved from the hunter walks 250 meters. 250 meters. Bearing is 042 degrees. So 250 meters. Right. Now this what we got from information given to us. The question says calculate correctly the nearest kilometer, the vertical height through which he has moved. So from this point, this is given to us. So from this point, vertical height given to us. Is the vertical height, and then it says B passes horizontal distance covered. So if we go here and then horizontal distance covered, so from x, y, this is the movement. If the vertical distance covered is moving northward, and then horizontal distance from north to the vertical horizontal to the west, that will be, so here is 90 degrees. This is our triangle, 90 degrees. Okay, so since we now have a right angle triangle, I'm going to put the distance at 250 meters. So using Pythagoras theorem, A to A. For A, we are going to calculate the vertical height through which he has moved. So using Pythagoras theorem, vertical height, and this will now give us using the sine ratio, this adjacent. So this is the cosine ratio. Using the cosine ratio, we're going to have cos 42 degrees is equal to adjacent. So let's call here xz adjacent, which is xz over hypotenuse, which is 250. So line xz is equal to 250 cos 42 degrees, which is equal to 250 cos 42, 185.79, 125.79 to, right, so the nearest kilometer, so this will give us 126 kilometers to the nearest kilometers. Okay, and B will give us, this is E. So for B, we're supposed to calculate the horizontal distance covered. So the horizontal distance covered will give us which ratio is this? This is opposite of hypotenuse. So using the sine ratio, we're going to have our opposite is xz, line xy, line xy is equal to line xy as sine 42 degrees equal to line xy over 250. So line xy is equal to 250 sine 42 degrees. So line xy is equal to 250 sine 42, 167.28, and line xy is equal to xy is equal to 167 kilometers to the nearest kilometers. So what you observe is that the question directly, let your analysis direct you on what to do. So here I did not use sine or cosine rule because it's not necessary. What is necessary here is just the sine ratio. So let it direct you. But you can still use the sine rule if you wish. If you use the sine rule, you still get an answer because you have a known angle and a known side, and then a known angle and either of the side. So you are going to get this side, that is this angle, and then if you're going to get this side, this angle sum to get this angle, and then you can see the sine rule here also. And you can try that as an exercise to see if it's the same as what was gotten when we use the trig ratios instead. Points P and Q are respectively 24 meters and 7 meters east of point R. What is the bearing of Q from P to the nearest degree? So we need to be careful when analyzing this question because of the way the question is constructed. Points P and Q, so let's take each of them individually. Point P, which is 24 meters, is east of point R. So point P came first, so east of point R. So points P and Q are respectively 24 meters and 7 meters east of point R. So it's a mistake here. 24 meters north, okay, and 7 meters east of point R. So points P and Q are respectively 24 meters north and 7 meters east of point R. So if that is the case, so P, cardinal point P is travel north. Alright, this is not a north, travel north. You're going to have 24 kilometers from P. So the question says point P is 24 meters north of point R. So this is R rather of R. So R is the starting point. So 24 meters north. Oh, this is south. What am I doing? 24 meters north of R will give us P, point P. So the bearing of P from R is 24 meters north upwards. So stop here. That's a cardinal point. So this will give us point P. This is 24 kilometers to km. Okay, so that says and 7 meters east of point R. So 7 meters east of point R, we come this way, east of R. That's and this will give us Q, point Q. And this is 7 meters. And you join your points together. So that's it. So now the question says, what is the bearing of Q from P to the nearest degree? The bearing of Q from P. The bearing of Q from P would be, what's the line connecting P and Q? Is this line. So draw your angle, let it meet Q. Okay, so which means for you to get here, since this is northward, not southward, then this angle is needed so that P, this, let's call this theta, which is the bearing of Q from P. Now theta, we should get theta, we need to subtract this angle from 180 degrees to get theta, because this, both theta and let's call this alpha, are angles on a straight line. So yeah, or supplementary angles. So to get the bearing of Q from P, we want to know alpha. We can subtract alpha from theta to get the value of, no, we can subtract alpha from 180 degrees rather to get the value of theta. So first of all, let's solve to get alpha. So this is 90 degrees. Since we don't, the question did not want us to get the distance between P and Q, so let's go right away to our question. So can we use sine rule? No, we can't use sine rule. So what do? We are going to use trig ratio. This is opposite over adjacent, so that's tan. So using the tan, using tan ratio or tangent, using tangent ratio. So we're going to say tan alpha is equal to opposite, which is 7 over adjacent 24. So tan alpha is equal to alpha 7 divided by 24. We give us 0.2917. So alpha is arc tan 0.2917. Alpha will give us 0.2917, 16.26 degrees. So alpha is 16.26 degrees. Remember, the bearing of Q from P is 180 degrees minus is theta. Okay, is theta equal to 180 degrees minus alpha. Why? Angles on a straight line. Angles on a straight line. That's the reason. So theta is equal to 180 degrees minus 16.26 degrees. So theta is equal to 180 minus 16.26. That is 163.74 degrees. Therefore, okay, so to the nearest degree, before we put our final note, so we're going to say theta approximately is equal to 164 degrees to the nearest degree. So therefore, the bearing of Q from P is 164